The Valentine tank was obsolete before the first production model rolled off the assembly line in May 1940, a design dismissed by British military planners as too small, too slow, and too lightly armed to matter in modern mechanized warfare. Yet by 1943, Soviet commanders were specifically requesting more Valentine tanks than any other Allied vehicle, insisting on continued shipments even as newer, more powerful tanks became available. German intelligence reports captured after battles on the Eastern Front revealed a grudging respect for this British infantry tank that Soviet crews nicknamed the Little Sweetheart, a machine that somehow survived the frozen hell of the Moscow counteroffensive, the grinding attrition of Stalingrad, and the apocalyptic tank battles at Kursk. The Valentine became the single most numerous foreign tank in Red Army service, with over 3,300 delivered through Arctic convoys and Iranian rail routes, accounting for roughly 30% of Soviet medium tank strength during the critical winter of 1941-42, when the fate of Moscow hung by a thread. Before we go deeper into how this decision changed the course of the war forever, make sure to subscribe for more history that actually happened. The story begins not in the corridors of Soviet power or on the frozen steppes outside Moscow, but in a private design office at Vickers Armstrong Limited in Newcastle upon Tyne, England, where in late 1937 a team of engineers wrestled with an impossible problem. Britain's rearmament program demanded infantry tanks, heavily armored vehicles designed to support foot soldiers in direct assault, but the existing designs were catastrophically expensive and slow to produce. The Matilda II, pride of British tank design, required nearly 2 years from order to delivery, consumed massive amounts of strategic materials, and cost the equivalent of feeding a battalion for 6 months. War was coming. Everyone knew it. The question was whether Britain could field an armored force before the shooting started. John Valentine Carden, Vickers' chief tank designer, had been killed in an aircraft accident in December 1935, but his design philosophy lived on in the drawing boards and prototype workshops. Carden had believed in pragmatism over perfection, in designs that could be built quickly by civilian industry rather than specialized armament factories. His successors at Vickers examined the A-10 cruiser tank and A-11 infantry tank and saw not just vehicles but a manufacturing philosophy. What if they stripped away everything non-essential? What if they accepted compromises in the name of production speed? What if they designed a tank that could be built in railway workshops rather than dedicated armor facilities? The proposal landed on War Office desks on February 10, 1938, Valentine's Day, though whether this was intentional or coincidental remains disputed. The design was radical in its conservatism. Instead of the three-man turret standard in British doctrine, the Valentine mounted a cramped two-man turret with the commander forced to double as gunner. Instead of powerful but scarce engines, it used variants of existing commercial bus and lorry motors. Instead of complex suspension systems, it employed a modified three-wheel horseman bogie design already proven in service. The armor was respectable for its time, 65 millimeters on the turret front, 60 millimeters on the hull glacis, but achieved through simple vertical or gently sloped plates rather than complex castings. The main armament was the standard QF 2-pounder gun, already in production, firing a 40 millimeter armor-piercing shot capable of penetrating 47 millimeters of vertical armor at 500 meters. The War Office rejected it. The reasons were bureaucratic rather than technical. The Valentine didn't fit approved specifications. Its two-man turret violated doctrine requiring a dedicated commander. Its use of commercial engines contradicted policies favoring purpose-built tank power plants. Most damningly, it was a private venture, unsolicited, arriving at precisely the moment when military planners were standardizing on approved designs. In April 1939, with war 6 months away, Vickers was informed their tank would not be ordered. Then France fell. Between May 10th and June 22nd, 1940, the Wehrmacht tore through French and British defenses with a speed that left military observers stunned. British Expeditionary Force tanks were abandoned on the beaches of Dunkirk. The army had evacuated its men, but left nearly all its armor in France. Britain faced the possibility of invasion with a tank force that could be counted in dozens rather than hundreds. Suddenly, the Valentine's compromises looked like virtues. Who cared about a cramped turret when the alternative was no tank at all? Who worried about commercial engines when production could start immediately? The first production order arrived in July 1940. Vickers' Newcastle-upon-Tyne facility would produce 500 units. Metro Camel Carriage and Wagon Company in Birmingham would build 300. Birmingham Railway Carriage and Wagon Company would manufacture 200. These were not tank factories. They were firms that built railway carriages, buses, and commercial vehicles. This was precisely the point. The Valentine could be manufactured anywhere with heavy engineering capability, could be assembled by workers who had never seen a tank before, could use components from existing supply chains. By May 1940, the first Valentines were rolling out of factories at a rate of 30 per month. By the end of 1941, production reached 45 tanks per week across multiple British manufacturers. But Britain wasn't the only nation desperate for tanks. In June 1941, Operation Barbarossa shattered the Red Army's armored forces. German intelligence estimated Soviet tank losses at 20,000 vehicles in the first 6 months of the invasion. Soviet factories in Kharkov, Leningrad, and Kiev were overrun or evacuated east of the Ural Mountains. The industrial capacity to replace these losses didn't exist, not immediately, not while factories were being disassembled and shipped eastward on railway flat cars, not while workers were being conscripted into infantry divisions. The Soviet Union needed tanks from somewhere, anywhere, immediately. Winston Churchill and Franklin Roosevelt had both pledged material support to the Soviet Union within days of the German invasion. The question was what to send and how to deliver it. American tank production was still ramping up. British production was committed to re-equipping the army after Dunkirk and supplying forces in North Africa. But the Valentine represented surplus capacity. Canadian factories in Montreal were beginning Valentine production specifically for Lend-Lease export. The first shipment could be ready by autumn 1941 if convoy routes could be established. The northern route to Murmansk and Arkhangelsk was a nightmare of geography and logistics. Convoys would sail from Iceland or Scotland, cross the Arctic Ocean north of Norway, thread through German air bases in occupied Norway and Finland, avoid U-boat concentrations, survive Luftwaffe attacks, and finally reach Soviet ports, often locked in ice. The journey covered nearly 2,000 nautical miles through some of the most hostile waters on Earth. Ships would face 24-hour daylight in summer, making them visible to German reconnaissance aircraft around the clock, or 24-hour darkness in winter, forcing navigation through ice fields without visual reference. Water temperature hovered around 0 degrees Celsius. A man overboard would survive perhaps 10 minutes before hypothermia caused unconsciousness. The first Valentine tanks destined for Soviet service were loaded aboard merchant ships at Hvalfjord, Iceland, in September 1941 as part of Convoy PQ-1. 40 Valentine tanks, crated and secured in cargo holds, accompanied by spare parts, ammunition, and British technical manuals hastily translated into Russian. The convoy reached Arkhangelsk without loss. Within weeks, those tanks were uncrated, assembled, crew-trained, and dispatched south toward Moscow. German forces stood 30 kilometers from the Kremlin. Soviet intelligence reported that Wehrmacht units had requisitioned winter clothing from Moscow department stores, so certain were they of imminent victory. The Red Army had lost entire armies in the Kiev encirclement, had watched Leningrad surrounded and starved, had abandoned Smolensk, Minsk, and a dozen other cities. But the autumn Rasputitsa, the season of mud, had slowed German logistics. Roads dissolved into impassable quagmires. Tanks bogged down axle-deep. Supplies that once moved by truck convoy now crawled forward by horse-drawn wagon. The Wehrmacht's advance stalled not from Soviet resistance, but from the simple physics of mud. Soviet Marshal Georgy Zhukov recognized the opportunity. The Germans had outrun their supply lines, had spread their forces thin across hundreds of kilometers of front, had failed to prepare for winter operations because they'd expected to win before the first snow. If the Red Army could mass fresh divisions, could bring up reserves from Siberia and the Far East, could strike before the ground froze hard enough for German mobility to resume, they might push the invaders back from Moscow's gates. The 136th, 137th, 138th, and 139th Independent Tank Battalions received their Valentine tanks in late November 1941. Soviet tankers trained for less than 2 weeks. There wasn't time for more. The battalions were deployed to the Western Front defending Moscow, assigned to support rifle divisions in the counteroffensive plan for December 5th. 97 Valentine tanks rolled into position, their crews struggling to master British controls, British instruments, British procedures in a language most barely understood despite translation manuals. The Valentine's design reflected British tank doctrine circa 1938, which emphasized infantry support over independent maneuver. The tank's maximum speed of 24 kilometers per hour on roads made it slower than most contemporary designs, but this was intentional. Infantry tanks weren't supposed to race ahead of foot soldiers. They were supposed to advance at walking pace, providing mobile firepower and armor protection for infantry assault. The Valentine's armor, 60 to 65 millimeters on frontal surfaces, was proof against standard German 37mm anti-tank guns at combat ranges. The QF 2-pounder gun could penetrate 50 millimeters of armor at 500 meters, sufficient to deal with Panzer III and early Panzer IV tanks if aimed at vulnerable points. But the Soviet crews quickly discovered characteristics British doctrine hadn't anticipated. The Valentine was small. At 5.4 meters long and 2.6 meters tall, it presented a minimal silhouette, making it difficult to spot in snow-covered terrain or forest edges. The narrow tracks, 8 millimeters wide, and light weight of 17 tons gave it ground pressure of about 1 kilogram per square centimeter, allowing it to traverse snow that bogged down heavier Soviet tanks. The General Motors 2-cycle diesel engine started reliably in temperatures that froze gasoline engines solid. Soviet mechanics familiar with diesel locomotives found the power plant comprehensible, maintainable with available tools and skills. The counteroffensive struck on December 5, 1941, in temperatures plunging to minus 30 degrees Celsius. German soldiers, still wearing summer uniforms with inadequate overcoats, found their weapons frozen, their vehicles immobilized, their confidence shattered. Soviet forces, equipped for winter warfare, attacked along multiple axes simultaneously. The Valentine battalions advanced alongside T-34 and T-60 tanks, grinding forward through snow-covered forests and frozen fields. A German intelligence report captured after the Battle of Moscow documented the first Valentine encounter. 3 Valentine tanks from the 138th Independent Tank Battalion engaged a German defensive position on November 28 during preliminary operations. The Germans initially misidentified them as captured Soviet tanks, confused by the unfamiliar silhouette. When the Valentines opened fire with 2-pounder guns, German infantry deployed 37mm pack anti-tank guns, achieving hits but failing to penetrate frontal armor. 2 of the 3 Valentines were eventually disabled by 88mm anti-aircraft guns repositioned for anti-tank work, but the third withdrew successfully, demonstrating that British armor protection standards could withstand standard German anti-tank weapons. German quartermaster records showed panic requisitions for heavier anti-tank guns after encounters with Valentine-equipped units. The 37mm Pak 36 standard German infantry anti-tank weapon proved inadequate. German soldiers had already nicknamed it the door knocker for its inability to penetrate Soviet T-34 and KV-1 tanks. The Valentine, while not as heavily armored as those designs, still resisted 37mm fire at combat ranges. Wehrmacht units facing Valentine battalions demanded 50mm Pak 38 guns, or preferably 88mm flak guns in direct fire roles. Soviet reports from the 146th Tank Brigade, which received Valentines in early 1942, praised the tank's reliability. The brigade commander noted that Valentines required less maintenance than T-34 tanks, experienced fewer mechanical breakdowns, and could operate longer between major overhauls. The diesel engine consumed less fuel than gasoline engines of equivalent power, extending operational range. The suspension proved robust, handling rough terrain without frequent track or bogie failures. In one documented incident, a Valentine drove over 100 kilometers through snow-covered forest to rejoin its unit after becoming separated during a night march. The tank reached friendly lines without mechanical assistance, the crew reporting only minor wear on track pins. But Soviet crews also identified serious flaws. The 2-pounder gun, while adequate against early war German tanks, struggled against improved armor. The gun fired solid shot without explosive filler, meaning penetration alone determined effectiveness. Against infantry, fortifications, or soft targets, the 2-pounder was nearly useless. Soviet tankers, accustomed to the T-34's 76mm gun capable of firing high-explosive shells, found the Valentine unable to suppress German anti-tank positions or engage enemy infantry effectively. The cramped 2-man turret forced the commander to operate the gun, load ammunition, observe the battlefield, and direct the driver simultaneously. Soviet doctrine preferred 3-man turrets with dedicated gunners and loaders, allowing commanders to focus on tactical decision-making. The narrow tracks, advantageous in light snow, became liabilities in deep powder or icy conditions. Soviet engineers reported that snow packed between the 3-wheel bogie assemblies, freezing solid overnight, and jamming the suspension. Crews learned to clear packed snow with entrenching tools and blowtorches after each day's operations, adding an hour of maintenance to evening routines. Track tension required constant adjustment as metal contracted in extreme cold, loosening track until it threw cleats or derailed entirely. Soviet modifications began arriving at refurbishment depots by spring 1942. The most common field modification was the addition of external fuel tanks, extending range from 140 kilometers to over 200. Crews welded improvised tool racks to hull sides, carrying spare track links, tow cables, and entrenching tools accessible without opening hatches. Some units installed 12.7mm DSHK machine guns on turret roofs for anti-aircraft defense, although this required fabricating mounting brackets and ammunition storage. The most ambitious modification involved cutting new pistol ports in turret sides, allowing crew to fire personal weapons without opening hatches, a lesson learned from German infantry assaults on immobilized tanks. Soviet signal troops faced a peculiar problem: British radio sets. The Valentine came equipped with a number 19 wireless set, a sophisticated radio by 1941 standards, capable of voice communication and Morse code transmission over ranges exceeding 10 kilometers. But Soviet signal doctrine used different frequencies, different communication protocols, different codes. Some Valentines received Soviet radio sets pulled from scrapped T-26 tanks, installed alongside British radios in makeshift dual installations. Others had British radios removed entirely, replaced with Soviet equivalents. The least fortunate units simply operated without radios, relying on flag signals and visual communication, a dangerous expedient in fluid combat. The Lend-Lease pipeline grew more organized through 1942. Convoys became routine despite horrific losses. Convoy PQ-17, which sailed in June 1942, lost 23 of 35 merchant ships to German U-boats and aircraft after the Admiralty ordered the convoy to scatter. Among the sunken cargo, 450 Valentine tanks at the bottom of the Arctic Ocean. But convoys continued. PQ-18 in September delivered 38 of 42 ships despite losing 13 to attacks. By the end of 1942, over 1,300 Valentine tanks had reached Soviet ports despite convoy losses approaching 30%. Canadian production became critical to maintaining supplies. The Canadian Pacific Railway's Angus shops in Montreal converted from locomotive manufacturing to tank production in 1940. By 1942, the facility employed 3,500 workers building Valentine tanks specifically for Soviet Lend-Lease. Each tank contained 40,000 individual parts, cost $90,000 Canadian, and weighed 28 tons fully equipped. Production reached 3 tanks per day, rolling off assembly lines and loaded directly onto railway cars for transport to Canadian ports. Of the 1,420 Canadian-built Valentines, 1,388 were shipped to the Soviet Union, representing over 98% of Canadian Valentine production. Canadian Valentines differed slightly from British models. They used General Motors Detroit diesel two-cycle engines instead of British AEC petrol engines, providing more reliable cold weather starting. The tracks were slightly wider, reducing ground pressure. The glacis armor increased to 70 millimeters in some variants. Most significantly, Canadian production switched to 6-pounder guns for later models, more than doubling penetration capability compared to 2-pounder weapons. Soviet requests specifically mentioned preference for Canadian Valentines with 6-pounder armament, a remarkable detail, showing Soviet attention to variant specifications. By 1943, Valentine tanks equipped Soviet tank brigades across multiple fronts. The 5th Guards Tank Army included Valentine-equipped regiments during the Battle of Kursk in July 1943. The 15th and 36th Heavy Tank Regiments fielded 42 Valentine tanks during the fighting around Prokhorovka, assigned to support infantry in defensive positions rather than counterattacking German armor. Soviet commanders had learned to employ Valentines according to British infantry tank doctrine. Hull-down positions, supporting infantry, engaging targets at medium range rather than attempting to match German Tigers and Panthers in mobile warfare. The Valentine's reputation among Soviet troops was complex. Dmitry Loza, who commanded an American Sherman tank and later wrote memoirs about Lend-Lease armor, noted that crews called the Valentine the Little Sweetheart with genuine affection despite its limitations. The nickname reflected the tank's reliability, its tendency to bring crews home alive even when damaged. Valentine frontal armor, though not as thick as T-34 or KV-1 tanks, was well sloped for its era and proof against most German anti-tank weapons except at close range. The compact size made it a difficult target. Crews reported that German gunners often missed first shots against Valentines because they underestimated range, expecting a larger silhouette. But the nickname also carried a note of condescension. A sweetheart was not a fearsome weapon. Soviet tankers respected the Valentine for keeping them alive, but didn't trust it to win battles. The 2-pounder gun, even in units with 6-pounder upgrades, remained inferior to the T-34's 76mm weapon. The cramped turret meant slower rate of fire compared to Soviet tanks with dedicated loaders. The narrow tracks limited tactical mobility in mud and deep snow despite advantages in light snow. Soviet crews preferred Valentine assignments for survival, but not for glory. German assessments revealed grudging respect mixed with tactical dismissal. A German intelligence summary from February 1943 described the Valentine as a well-protected tank with good reliability but insufficient armament for modern combat. Its small size makes it difficult to observe and engage at range. However, its gun cannot penetrate improved German armor, rendering it primarily a defensive weapon. This assessment was both accurate and incomplete. The Valentine wasn't designed to penetrate Panther or Tiger frontal armor. No medium tank of 1941 to 42 vintage could reliably do so. What the Valentine could do was hold defensive positions, support infantry attacks, engage German Panzer IIIs and IVs at medium range, and survive to fight again. In the grinding attrition warfare of the Eastern Front, survival mattered more than spectacular performance. The Valentine served in unexpected roles beyond direct combat. Soviet self-propelled gun crews mounted 76mm guns on Valentine chassis, creating improvised tank destroyers when dedicated Su-76 vehicles were unavailable. Signals units converted Valentines into armored command vehicles, stripping out weapons and installing additional radios and map tables. Engineer units used Valentines as armored recovery vehicles, their reliable engines and robust construction allowing them to tow disabled tanks from battlefields under fire. Medical battalions experimented with Valentine-based armored ambulances, though the cramped interior limited this application. The Valentine's greatest contribution may have been timing rather than capability. Soviet tank production didn't fully recover from 1941 losses until mid-1943. The T-34 factories evacuated to Nizhny Tagil, Chelyabinsk, and Omsk took months to resume full production. During this critical gap, Lend-Lease armor, including Valentines, filled Soviet tank brigades that would otherwise have gone unequipped or understrength. At the Battle of Moscow in December 1941, Lend-Lease tanks, including Valentines, represented roughly 25% of Soviet medium tank strength on the Western Front. Without those tanks, Soviet counteroffensive forces would have been significantly weaker. Soviet post-war assessments provide the most balanced view. A 1943 report from the main armored directorate acknowledged that the Valentine tank, while not meeting Soviet requirements for armament, provides acceptable armor protection and excellent mechanical reliability. It is particularly suitable for training units, second-line formations, and defensive operations where its limitations are less critical. This carefully diplomatic language translates to, the Valentine wasn't the tank Soviet designers would have built, but it was the tank available when availability mattered more than perfection. Soviet tanker Anatoly Kozlov, who served in a Valentine-equipped unit near Leningrad in 1942, later recalled that his crew painted their tank number in yellow on the turret and named it Moscow despite the fact that they'd never seen the Soviet capital. They chose the name because they believed the Valentine had helped save Moscow from capture in December 1941 before they'd even joined the army. This mythology that foreign tanks had rescued the motherland existed uncomfortably alongside Soviet pride in domestic engineering. Official histories emphasized Soviet-designed T-34 and KV-1 tanks while downplaying Lend-Lease contributions. But soldiers who crewed Valentines remembered the foreign tanks differently, with the complicated gratitude of men who knew they'd survived battles they might not have without them. By 1944, the Valentine was obsolescent even by Soviet standards. The upgun T-34-85, with its 85mm gun, far outclassed any Valentine variant. Soviet tank production reached 29,000 vehicles in 1944, dwarfing Lend-Lease deliveries. Valentine tanks were relegated to training roles, second-line units, and occupation forces where combat likelihood remained low. The last Valentine shipments arrived in Soviet ports in early 1944, after which Soviet authorities requested Shermans instead, a tacit acknowledgement that newer designs had surpassed British infantry tanks. Yet Soviet commanders continued to appreciate the Valentine's specific virtues. Marshal Zhukov, in his memoirs, mentioned that Lend-Lease tanks, despite their shortcomings, provided essential reinforcement when Soviet industry was incapable of meeting the Red Army's needs. He didn't specify Valentine tanks, but the timing, late 1941 through 1942, makes clear which foreign tanks he meant. Zhukov wasn't given to excessive praise of Allied contributions, making even this measured acknowledgement significant. The Valentine remained in Soviet service through the end of the war and beyond. Units stationed in Manchuria during the August 1945 offensive against Japanese forces included Valentine-equipped battalions, fighting their last battles against an enemy the tanks had never been designed to face. Photographic evidence shows Valentines in Soviet victory parades in 1945, though not prominently. A few served with occupation forces in Eastern Europe through 1946. The last Valentines were probably scrapped in the early 1950s, their steel recycled into post-war industrial reconstruction. The story of the Valentine in Soviet service illustrates truths about industrial warfare that transcend specific machines. The Soviet Union needed tanks more desperately than it needed perfect tanks. British and Canadian industries could provide adequate tanks quickly, more quickly than Soviet factories could produce excellent tanks. The Valentine represented an industrial and logistical triumph rather than an engineering breakthrough. It solved the problem of how do we equip tank brigades now rather than how do we build the ultimate tank. The human cost of that industrial calculation remains harder to quantify. Soviet Valentine crews faced German guns in machines they knew were inferior to enemy armor in firepower, if not protection. They understood that their tanks couldn't penetrate Panther frontal armor, that their 2-pounder guns were obsolete by 1943 standards, that German commanders didn't particularly fear Valentines the way they feared T-34s or KV-1s. Yet they went into battle anyway, because someone had to, because the alternative was allowing German forces to advance unopposed, because survival meant accepting whatever equipment arrived through Arctic convoys and fighting with it. The casualty rates for Valentine-equipped Soviet units aren't separately documented in surviving records. Soviet casualty reporting aggregated losses by formation rather than by equipment type. But scattered references suggest Valentine crews suffered proportionally similar losses to other tank units, horrifically high by Western standards, grimly routine by Eastern Front measures. A 1943 Soviet report mentioned that a Valentine-equipped battalion lost 14 of 16 tanks during a 2-week period near Kursk, though whether to combat mechanical failure or abandonment remains unclear. What is clear is that the crews who survived spoke of their Valentines with the same mixture of frustration, affection, and respect that veterans show for any equipment that brought them through combat alive. The legacy of the Valentine in Soviet service is largely forgotten in both countries. British histories focus on North African campaigns where Valentines fought in British colors. Soviet histories emphasize domestically produced T-34s and KV-1s. The Valentine occupies an uncomfortable middle ground, too British for Soviet narratives of self-reliance, too Soviet for British narratives of imperial military achievement. Canadian contributions are even less remembered, despite Montreal factories producing more Valentines for Soviet service than for any other customer. Yet, the numbers tell their own story. Over 3,300 Valentine tanks reached Soviet ports despite convoy losses. They equipped over 50 independent tank battalions and numerous tank brigades. They participated in every major Soviet operation from Moscow to Berlin. They represented roughly 30% of Soviet medium tank strength during critical periods when that strength made the difference between holding and collapsing. The Valentine didn't win the war, but it helped prevent losing the war, which in late 1941 was the only victory that mattered. German commanders never feared the Valentine the way they feared T-34s or later IS-2 heavy tanks. German tank crews didn't paint kill marks on their turrets specifically for destroyed Valentines. German anti-tank gun crews didn't request special ammunition types to deal with Valentine armor. In the catalog of German nightmares on the Eastern Front, T-34s, Katyusha rockets, Winter Sturmovik ground attack aircraft, the Valentine barely registers. But that, in its way, is precisely the point. The Valentine wasn't supposed to terrify German tankers. It was supposed to show up, do the job, and bring its crew home. By that measure, it succeeded more often than many more celebrated designs. The final irony is that the Valentine validated British tank doctrine precisely by proving that doctrine inadequate. The British envisioned infantry tanks as slow, heavily armored vehicles supporting infantry attacks, armed with guns sufficient to defeat similar tanks, but not designed for independent operations. The Valentine embodied this vision perfectly. Soviet employment demonstrated both the concept's utility and its limitations. Yes, infantry tanks could support attacks and hold defensive positions effectively. But modern mechanized warfare demanded more mobile exploitation, deep penetration, combined arms coordination at operational scales. The Valentine could do what British doctrine intended, but couldn't do what modern warfare required. Soviet tank design learned lessons from Lend-Lease armor, including the Valentine. Post-war Soviet tanks incorporated reliable diesel engines, a technology demonstrated by Valentine and Sherman engines that started in conditions where Soviet gasoline engines failed. Soviet designers adopted better turret layouts after observing how cramped two-man British turrets reduced combat effectiveness. Soviet production planning incorporated manufacturing flexibility after watching how British and Canadian industries mobilized civilian factories for tank production. These lessons, absorbed and adapted, influenced Soviet tank development through the Cold War. The Valentine story ultimately reveals how wars are won not through individual weapon systems, but through the grinding calculus of industrial production, logistical delivery, and human endurance. The Soviet Union survived 1941 not because it had better tanks than Germany, it didn't despite T-34 mythology, but because it could lose 20,000 tanks and still field armies. Britain and Canada contributed to that survival, not through military genius, but through industrial capacity, mobilized to keep factories running when survival required every tank that could be built, shipped, and deployed. The Valentine was the right tank for that moment precisely because it could be produced quickly, shipped reliably, and used effectively by crews with minimal training. 332,000 Soviet tankers died during the Great Patriotic War, a casualty rate approaching 80% of total personnel who served in armored forces. Some significant fraction of those casualties served in Valentine tanks, though exactly how many will never be known. They fought in machines they understood were compromised, limited, insufficient. They fought anyway. They named their tanks Moscow and Victory and Revenge. They painted unit insignia on glassy plates and kept British instruction manuals translated into barely comprehensible Russian. They died in numbers that no Western military would have accepted as sustainable. And some survived, brought home by British engineering and Canadian production and their own skill, and a measure of luck that meant their tank took the hit that didn't penetrate, fought the battle that didn't overwhelm, retreated from the engagement that could be survived. The Valentine represents a peculiar category of military equipment. Not the best, not the worst, but available when availability mattered more than excellence. In that sense, it epitomizes total war industrial mobilization. The calculation that adequate equipment now beats excellent equipment later, that something is better than nothing when nothing means defeat. German industrial planning failed to make that calculation. Wehrmacht forces fought with insufficient production of excellent tanks, maintaining quality standards even as quantity became the decisive factor. Soviet and Allied industrial planning embraced the opposite approach: acceptable quality in massive quantity, overwhelming numerical superiority compensating for individual technical inferiority. The Valentine served in Soviet colors longer than in British service, fought in more battles, covered more kilometers, and destroyed more enemy vehicles than in any other army. Yet, it remains largely unknown in popular understanding of World War II armor. This obscurity reflects broader patterns in how wars are remembered. We recall the exceptional Tiger tanks, T-34 Shermans, while forgetting the adequate, the sufficient, the machines that simply showed up and did the job they were given. The Valentine deserves better. Not glory, which it never sought, but recognition for the role it played when the war's outcome hung uncertain, and every tank, every ton of steel, every engine that started in -30° weather represented the margin between survival and catastrophe. If this story gave you a new way to see World War II on the Eastern Front, share and subscribe, and tell us which moment surprised you most. We'll return next week with another chapter in the war that changed the world. The arithmetic of survival on the Eastern Front reduced warfare to brutal simplicity. Soviet tank factories east of the Urals produced vehicles at rates that shocked Western observers. Stalingrad, the nickname for Chelyabinsk tractor plant, rolled out T-34s at a pace of 8 per day by mid-1942. Yet, even this prodigious output couldn't replace losses fast enough. German summer offensives in 1942 destroyed tanks faster than factories could build them. The gap between production and attrition demanded external supply, which meant Lend-Lease, which meant Valentine tanks arriving through Arctic convoys at precisely the moment when any tank mattered more than the best tank. The journey from Montreal or Newcastle to Moscow spanned not just geography, but ideologies. Workers in Canadian Pacific Railway shops had never seen the Soviet Union, couldn't locate Arkhangelsk on a map, probably harbored the same suspicions of communism that characterized Western societies in the 1940s. Yet they built tanks knowing Soviet crews would crew them, fight in them, possibly die in them. The disconnect between production and employment created its own mythology. Canadian newspapers published photographs of Valentine tanks rolling off Montreal assembly lines with captions about aid to our Russian allies, without mentioning that those allies had been Nazi allies less than 2 years earlier, that the Molotov-Ribbentrop Pact had facilitated the partition of Poland, that Soviet and German forces had cooperated in crushing Polish resistance. Wartime propaganda required simplification. The enemy of my enemy became my ally without dwelling on inconvenient history. British factories operated under different pressures. Bomber Command demanded resources. The Mediterranean theater consumed shipping. North African campaigns devoured armor. Every Valentine sent to the Soviet Union represented a Valentine not available for British use. Churchill's decision to prioritize Soviet supply reflected strategic calculation rather than sentiment. Britain couldn't defeat Germany alone. Soviet resistance, even Soviet survival, was essential to preventing German consolidation of European resources. If Valentine tanks kept Soviet armies in the field, those tanks served British interests regardless of where they fought. The calculus was cold, but logical. Better to equip Soviet crews who would face 90% of Wehrmacht ground forces than to hold tanks in reserve for operations engaging 10% of German strength. The men who sailed those convoys understood the stakes viscerally. Merchant sailors on the Murmansk run faced mortality rates higher than infantry soldiers. A ship torpedoed in Arctic waters offered crew perhaps 5 minutes of survival before hypothermia induced unconsciousness. Life rafts were futile in seas where exposed skin froze in minutes. Ships that caught fire from bomb strikes faced equally grim choices: burn alive or jump into water cold enough to stop hearts. The sailors knew this. They sailed anyway, some for patriotism, some for wages triple normal merchant marine rates, some because they'd signed contracts and desertion meant prosecution. Their motivations mattered less than their actions. They delivered the cargo or died trying, and enough succeeded to keep Soviet tank battalions equipped through the war's darkest period. Soviet port workers at Arkhangelsk and Murmansk unloaded ships under conditions nearly as dangerous as the voyage itself. German bombers targeted the ports constantly. Luftwaffe reconnaissance flights photographed convoy arrivals, targeting subsequent raids on cargo still dockside. Workers unloaded Valentine tanks from holds while air raid sirens wailed, racing against time to disperse cargo before the next attack. The ports themselves existed in a state of perpetual reconstruction, bomb damage repaired just in time for the next raid to destroy the repairs. Winter added another dimension of misery. Temperatures plunged to -40 Celsius. Metal became brittle enough to crack under load. Cranes froze solid. Workers operated in darkness 20 hours per day during winter months, their only illumination flickering electric lights and occasional German flares illuminating targets for bombers. The railway journey south from Arctic ports covered 1,500 kilometers through landscape alternating between taiga forest and tundra plain. Single-track lines built to imperial Russian standards from the 1890s carried traffic volumes they'd never been designed to handle. Valentine tanks rode flat cars, exposed to weather, secured with chains and chocks. The trains moved slowly, sometimes averaging 15 kilometers per hour, stopping frequently to allow higher-priority ammunition and fuel trains to pass. Entire convoys could spend days on sidings waiting for traffic clearance. German saboteurs occasionally struck these supply lines, though partisan activity and simple mechanical failure caused more delays than enemy action. By the time Valentine tanks reached frontline depots, they'd already endured journeys that would have qualified as significant campaigns by Western standards. Soviet reception depots established procedures for processing Lend-Lease armor. Technical teams inspected each tank for damage, inventoried included spare parts and ammunition, cross-referenced British technical manuals with Soviet maintenance protocols. The challenges weren't trivial. British and Soviet engineering traditions used different fastener standards, different lubricants, different replacement part systems. A Valentine requiring a new track link couldn't use Soviet T-34 tracks. Broken idler wheels needed British specification replacements. Soviet logistics struggled with this parts incompatibility. Some units cannibalized damaged Valentines to keep operational tanks running. Others improvised repairs using Soviet components modified to fit British specifications. The most successful units maintained dedicated Lend-Lease maintenance crews trained specifically on British and American equipment, a luxury most formations couldn't afford. Soviet training regimens for Valentine crews compressed into periods British doctrine would have considered dangerously inadequate. A British Valentine crew trained for 6 to 8 weeks before deployment. Soviet Valentine crews received 1 to 2 weeks of familiarization before assignment to combat units. The difference reflected necessity rather than preference. The Soviet Union couldn't afford extended training cycles when German forces advanced toward Stalingrad and the Caucasus oil fields. Tank crews learned basics, how to start the engine, operate controls, fire the gun, then learned advanced skills through survival or death. This brutal pedagogical method produced wildly variable crew quality. Some became expert Valentine operators within weeks. Others died in their first engagement through mistakes more experienced crews would have avoided. The Valentine's mechanical reliability proved its greatest virtue in this abbreviated training environment. British engineering emphasized simplicity and robustness. The Valentine's controls, while unfamiliar to Soviet crews trained on T-34s, followed logical patterns that skilled drivers mastered quickly. The General Motors diesel engine, while different from Soviet power plants, operated on principles Soviet mechanics understood from locomotive and generator maintenance. The transmission, suspension, and steering mechanisms tolerated operator error without catastrophic failure. A novice driver could stall the engine, miss gear changes, or brake too hard without causing damage requiring depot-level repairs. This forgiveness extended operational life significantly compared to more temperamental designs. Soviet tactical employment of Valentine tanks evolved through trial and error. Initial doctrine treated them as interchangeable with Soviet medium tanks, assigning Valentines to roles designed for T-34s. This proved disastrous. Valentines lacked the speed for mobile warfare, the firepower for tank versus tank duels, the armor for frontal assaults against prepared positions. Units equipped with Valentines and expected to perform T-34 missions suffered disproportionate losses and accomplished little. By mid-1942, Soviet commanders developed more appropriate employment doctrines. Valentines worked best in defensive positions, using their low silhouette and respectable armor to create strong points. They excelled supporting infantry attacks against enemy infantry, where their machine guns and small profile compensated for limited main armament. They performed adequately in exploitation roles after breakthroughs achieved by heavier tanks, occupying captured positions and consolidating gains. The human dimension of Valentine's service rarely appears in historical accounts. Soviet tankers didn't leave the memoirs that Western crews published after the war. Stalin's Soviet Union didn't encourage personal narratives that might highlight individual experience over collective achievement. The few available accounts come from post-Soviet interviews with elderly veterans willing to discuss experiences long kept private. They describe Valentine tanks with complex emotions: gratitude for armor that stopped German shells, frustration with guns that couldn't penetrate German tanks, pride in keeping British equipment operational under conditions British crews never faced, resentment that their country needed foreign charity to survive. These contradictory feelings never resolved into simple narratives. The Valentine remains simultaneously salvation and reminder of weakness, capable equipment and inadequate substitute, foreign and familiar. German documents reveal more about Valentine performance than Soviet sources. Wehrmacht After Action reports meticulously documented enemy equipment, seeking tactical and technical intelligence. German analysts noted Valentine armor thickness, gun penetration capability, mobility characteristics, crew tactics. A March 1943 report from Army Group Center described Valentine-equipped Soviet units as defensively competent but offensively limited. The tank's armor provides effective protection against standard anti-tank weapons at medium range, requiring deployment of heavy anti-tank guns or tank destroyers for reliable engagement. However, the vehicle's low speed and weak armament prevent effective counterattack or exploitation operations. This assessment, while technically accurate, missed strategic significance. Soviet doctrine by 1943 didn't require Valentines to counterattack or exploit. Those missions belonged to T-34 and KV-1 tanks. Valentines held positions, allowing mobile forces to concentrate for breakthrough operations. The Battle of Stalingrad provides case study in Valentine employment. The 62nd Army defending Stalingrad included multiple Valentine-equipped battalions by October 1942. Urban warfare negated many of Valentine's limitations while emphasizing its strengths. Low speed mattered less in city combat, where movement occurred street by street. Limited gun traverse proved less critical than in open terrain. Compact dimensions allowed Valentines to hide in rubble, occupy defensive positions in bombed buildings, traverse narrow streets heavier tanks couldn't navigate. Soviet accounts mention Valentines supporting infantry assaults on German-held buildings, providing covering fire from positions German infantry couldn't spot until too late. The tank's reliability mattered critically during winter months when temperatures plunged below -30°C and diesel engines that started when gasoline engines froze provided tactical advantage worth more than firepower superiority. Valentine losses during Stalingrad fighting remain statistically murky. Soviet loss reporting aggregated all armor losses regardless of type. German kill claims inflated actual achievements, as was standard for all combatants. Post-battle assessments suggest Valentine-equipped units suffered proportionally similar losses to T-34 units, though Valentines were less likely to be completely destroyed. British armor, while thinner than T-34 frontal plates, proved resistant to catastrophic ammunition detonation. German hits that would penetrate T-34 turrets and ignite ammunition, causing complete vehicle loss, often penetrated Valentine armor, but failed to destroy the tank outright. Crews had better survival rates. Tanks more often remained reparable. This seemingly technical detail had profound human implications. Tank crews who survived one engagement could apply lessons to the next. Units that recovered damaged tanks maintained higher operational strength than units losing tanks completely. The Valentine participated in the Kursk salient battles of July 1943, the largest tank engagement in history. Soviet forces defending the Kursk salient included Valentine-equipped units positioned in second defensive lines. German intelligence had identified Soviet defensive preparations, reporting multiple fortified lines with extensive anti-tank defenses. German planning assumed breakthrough operations would overwhelm forward defenses, necessitating rapid exploitation before Soviet reserves could intervene. Valentine units stationed in second-line positions entered combat after German forces penetrated initial defenses, fighting desperate holding actions while T-34 and KV-1 equipped formations maneuvered for counterattacks. The Valentine proved well-suited to this mission. Crews fought from prepared positions, maximizing armor protection and minimizing mobility limitations. German forces, already engaged with forward defenses, couldn't concentrate overwhelming firepower against individual strongpoints. Valentine units held positions long enough for mobile reserves to arrive, achieving tactical success despite technical inferiority to German armor. Soviet operational planning by 1943 incorporated Lend-Lease equipment into systematic force structure. Tank brigades received mixed equipment based on mission requirements and availability. A typical brigade might include 1 battalion of T-34s for offensive operations, 1 battalion of Valentines for defensive positions and infantry support, 1 battalion of light tanks for reconnaissance and exploitation. This mixed composition allowed commanders to match equipment capabilities to tactical requirements. German intelligence documents reveal confusion about this organization. German planners expected Soviet forces to concentrate best equipment in elite formations, leaving second-rate units with inferior tanks. Instead, Soviet doctrine distributed Lend-Lease equipment throughout force structure, creating consistently capable formations rather than sharp distinctions between elite and inferior units. The Valentine's twilight period began in 1944 as Soviet production finally exceeded replacement needs. New T-34-85 tanks with 85mm guns and improved armor rendered Valentine completely obsolescent for frontline service. Soviet logistics welcomed this transition, supporting mixed equipment types strained parts supply, maintenance training, technical documentation translation. Standardizing on Soviet-produced tanks simplified logistics dramatically. Valentine-equipped units received re-equipment orders, turning in British tanks for Soviet replacements. But complete replacement took months. Valentine tanks continued frontline service through mid-1944, fighting in Belarus liberation operations, supporting drives into Poland and Romania. The last Valentine combat operations probably occurred during the Vistula offensive in January 1945, though documentation remained sparse. Post-combat Valentine disposition varied by condition and location. Reparable tanks entered depot-level maintenance, emerging months later assigned to training units or reserve formations. Heavily damaged tanks were cannibalized for spare parts to maintain remaining operational vehicles. Completely destroyed tanks were scrapped, their steel recycled into Soviet industrial production. Some Valentines transitioned to non-combat roles. Engineer units converted them into armored recovery vehicles, ammunition carriers, command post vehicles. A few became static fortifications, buried hull-down and defensive lines with only turrets exposed. Photographic evidence shows Valentines in these roles as late as 1946. Soviet analysis of Lend-Lease armor influenced post-war tank development significantly. Soviet designers studying Valentine, Sherman, and Churchill tanks identified features worth incorporating into domestic designs. Reliable diesel engines became standard in Soviet tanks, building on lessons learned from Valentine and Sherman reliability. Improved turret layouts with three-man crews became universal after observing how British two-man turrets reduced combat effectiveness. Manufacturing techniques learned from studying British and American production methods streamlined Soviet tank production. The T-54 tank, entering production in 1946, incorporated these lessons while maintaining Soviet design philosophy. The result was arguably the most successful tank design of the Cold War, combining Western manufacturing efficiency with Soviet operational doctrine. The Valentine's historical reputation suffered from classification restrictions lasting decades after the war. Soviet authorities suppressed discussion of Lend-Lease aid, emphasizing Soviet self-reliance and downplaying foreign assistance. Western historians lacked access to Soviet archives documenting Valentine employment. British histories focused on North African campaigns where British crews operated Valentines. The result was historiographical gap, erasing Valentine's Eastern Front service from popular understanding. Post-Soviet archive openings in the 1990s provided documentation enabling more complete historical understanding, but by then public interest focused on Cold War rather than World War II equipment. Veterans who served in Valentine-equipped units carried memories independent of official histories. Boris Mihailovich Petrov, interviewed in 1998 at age 76, recalled his Valentine service near Smolensk in 1943. He described the tank as reliable but underpowered, adequately protected but insufficiently armed. Most vividly, he remembered the smell, machine oil, cordite, unwashed bodies confined in cramped space. British equipment smelled different from Soviet tanks, a detail meaningless to historians, but viscerally important to men who lived in those metal boxes. Petrov survived the war, his Valentine knocked out twice and repaired both times. He credited British armor for his survival, noting that German shells penetrating T-34s typically killed crews instantly through ammunition detonation, while Valentine penetrations, while dangerous, were more survivable. The final accounting of Valentine's Eastern Front service defies simple assessment. By metrics of technical superiority, the Valentine was inferior to contemporary designs. German Panthers and Tigers outclassed it completely. Even Soviet T-34 surpassed it in firepower and mobility. Yet, technical superiority wasn't the relevant measure. The Valentine arrived when Soviet armies desperately needed any tank. It fought competently in roles matching its capabilities. It brought crews home alive more often than many ostensibly superior designs. It filled gaps in Soviet force structure during the war's most critical phase. These achievements, while less dramatic than decisive battles or technical breakthroughs, mattered profoundly too. The men who crewed the tanks and the war's ultimate outcome. Historical memory of the Valentine reveals more about post-war politics than wartime reality. Soviet official history minimized Lend-Lease to emphasize Soviet self-sufficiency. British history focused on imperial forces in North Africa and Europe. Canadian contributions disappeared almost entirely from popular consciousness despite Montreal factories producing nearly 1,400 tanks. The Valentine became an orphan of history, too British for Soviet narratives, too Soviet for British remembrance, too prosaic for popular military histories preferring heroic narratives over industrial production statistics. Yet the story deserves telling precisely because it represents typical rather than exceptional. Most weapons in most wars are adequate rather than excellent, serve competently rather than heroically, and matter through cumulative effect rather than individual drama. The Valentine epitomizes these unglamorous truths about industrialized warfare. The mathematics of armor warfare on the Eastern Front defied Western comprehension. British tank battalions considered 20% losses catastrophic, requiring units to withdraw for reconstitution. Soviet tank brigades routinely suffered 70% losses in single operations and continued fighting with surviving vehicles. This disparity reflected not just different casualty tolerances, but fundamentally different military philosophies. Soviet doctrine accepted attrition as inevitable, planning for replacement rather than preservation. Tank brigades were expendable assets to be used completely rather than hoarded carefully. The Valentine fit this doctrine through its availability rather than its excellence. Soviet commanders could employ Valentine units aggressively because replacement tanks would arrive through Arctic convoys regularly, a calculation impossible with Soviet-produced armor during the critical 1941-42 period when production lagged desperately. The industrial capacity supporting Valentine production represented Allied strength beyond German matching. Vickers Armstrong's Newcastle facility, Metro Camel in Birmingham, Canadian Pacific Railway in Montreal. These factories operated in countries beyond German bomber reach, employed workers adequately fed and housed, received raw materials through secure supply chains. Compare this to Soviet tank production evacuated east of the Urals, operating in hastily constructed facilities where workers lived in dugouts and barracks without adequate heating, where machinery salvaged from evacuated factories arrived damaged and incomplete, where power supply remained sporadic and material shortages endemic. That Soviet factories produced tanks at all under these conditions represents remarkable achievement. That they couldn't produce enough tanks to meet losses while simultaneously dealing with these challenges surprises no one examining conditions objectively. Lend-Lease armor filled gaps that Soviet heroism alone couldn't close. German industrial planning failed to account for this Allied advantage. German factories produced technically superior tanks, Tigers with 88mm guns, Panthers with sloped armor and excellent optics, improved Panzer IVs with long-barreled 75mm weapons. But they produced them slowly, in insufficient numbers, unable to replace losses at rates matching Allied production. A single Tiger tank required 30,000 man-hours to construct, compared to 10,000 for a T-34 or 8,000 for a Valentine. German engineering prioritized quality over quantity, a peacetime luxury catastrophic in total war. By 1944, Allied factories produced over 8,000 tanks monthly while German production peaked at 1,500. The Valentine contributed to this quantitative superiority not through individual excellence, but through manufacturing efficiency enabling mass production. Soviet post-war assessment of Lend-Lease aid evolved through multiple phases, reflecting political requirements more than historical accuracy. Immediately post-war, Soviet authorities acknowledged Allied assistance while emphasizing Soviet primacy in defeating fascism. By the early Cold War, official histories minimized Lend-Lease contributions to near invisibility, presenting Soviet victory as achieved through Soviet resources alone. Khrushchev's 1963 memoirs offered more balanced assessment, acknowledging that without Lend-Lease, we would have lost, those specifying that Soviet soldiers fought and Soviet strategy won battles. Post-Soviet historians gained archive access, enabling detailed quantitative analysis. Their research revealed that Lend-Lease armor represented roughly 12% of Soviet tank strength averaged across the war, but 30 to 35% during crucial 1941 to 42 period when that margin made decisive difference. The Valentine specifically accounted for significant proportion of this Lend-Lease armor during critical period. Of 3,300 Valentines delivered, over 1,200 arrived before December 1942, providing tanks when Soviet production remained inadequate. Compare this to Sherman deliveries, which didn't reach significant numbers until 1943 when Soviet production had recovered. The Valentine's timing mattered more than its technical specifications. A tank available in December 1941 provided infinitely more value than a better tank available in June 1943. Soviet commanders understood this arithmetic viscerally, even if post-war historians sometimes missed the point. Soviet tactical doctrine evolved significantly through observing Lend-Lease equipment performance. British and American tanks emphasized crew survivability, mechanical reliability, and ease of production over maximum protection and firepower. Soviet tanks traditionally prioritized protection and firepower, accepting higher crew casualty rates. Exposure to Western design philosophy influenced Soviet thinking. Post-war T-54 and T-55 tanks incorporated improved crew ergonomics, better vision devices, more reliable engines, features learned from studying Valentine, Sherman, and Churchill tanks. The Valentine's contribution to Soviet tank development extended beyond its direct combat role into design philosophy, informing decades of subsequent production. Canadian contribution to Valentine production deserves particular emphasis given historical neglect. Montreal's CPR Angus shops transformed from locomotive manufacturing to tank production with remarkable speed. Workers accustomed to building railway locomotives applied those skills to tank construction, discovering that building tracked armored vehicles resembled building locomotives more than either industry initially recognized. Both required precision metalworking, complex drivetrain assembly, rugged construction withstanding harsh operating conditions. Canadian production achieved remarkable quality standards, with Soviet technical reports noting that Canadian-built Valentines with GM diesel engines proved more reliable than British-built versions with EC petrol engines. This quality reflected not just Canadian manufacturing expertise, but also benefit of newer purpose-built production facilities compared to British factories converted from other uses. The human cost of Valentine production remains difficult to quantify. Canadian factory workers didn't face combat danger, but they worked exhausting hours under intense pressure knowing their products would face desperate battles thousands of kilometers away. British factory workers endured German bombing throughout production periods, working through air raids to maintain delivery schedules. Soviet port workers unloading Valentine tanks at Murmansk and Arkhangelsk operated under constant Luftwaffe attack, suffering casualties that never appeared in combat statistics despite dying in war-related work. Soviet railway crews transporting tanks southward faced partisan attacks, German sabotage, and simply the brutal conditions of operating railways through Russian winter. Everyone in this chain, from Montreal factory worker to Soviet tank crewman, contributed to Valentine's operational deployment, and many paid steep prices for that contribution. The Valentine's mechanical simplicity proved advantageous beyond initial reliability. Damaged Valentines could often be repaired at field level by crews with basic tools. German tanks increasingly required specialized tools, factory-level repairs, replacement parts available only through dedicated supply chains. A Panther with damaged final drive needed depot-level repair because the drive unit comprised integrated components requiring specialized equipment to service. A Valentine with damaged final drive could often be repaired by crew using wrenches, hammers, and improvisation. This repairability extended effective combat life significantly. Tanks that reached battlefield remained operational longer when damage could be field repaired rather than requiring withdrawal to depot facilities, often hundreds of kilometers distant. Soviet modification of Valentine tanks went beyond documented depot-level changes to include uncounted field expedients. Crews welded spare track links to hull fronts for additional protection. They fabricated external fuel tank mounts from scavenged materials. They installed captured German optics when available because German optics outperformed. British equipment. They painted slogans on turrets and hulls, personalizing machines in ways Soviet regulations officially discouraged, but commanders tacitly permitted because crew morale mattered more than uniform appearance. A Valentine in Soviet service by 1943 bore little resemblance to factory-fresh British vehicles transformed through repairs, modifications, and accumulated battle damage into uniquely Soviet machines despite British origins. The Arctic convoy crews who delivered Valentines deserve recognition equivalent to frontline combatants. Merchant sailors faced U-boat torpedoes, Luftwaffe bombs, surface raider attacks, and natural conditions hostile enough to kill without enemy action. Convoy PQ-17's destruction in July 1942 demonstrated these dangers dramatically. Of 35 merchant ships sailing from Iceland, only 11 reached Arkhangelsk. 24 ships sank taking their cargoes, including hundreds of Valentine tanks, to Arctic seabeds where they remain today. Convoy PQ-18 in September 1942 fought through successfully despite losing 13 of 40 ships. These merchant sailors weren't soldiers, wore no uniforms, received no combat decorations. Yet they fought battles as desperate as any infantry engagement, died as certainly as any soldier, and contributed as directly to Soviet survival. Without their courage and sacrifice, Valentine tanks would have remained in Canadian and British warehouses rather than serving on Soviet battlefields. The Valentine's ultimate contribution transcended specific technical capabilities to represent Allied cooperation despite ideological differences. Democratic capitalist nations built tanks that Communist Soviet Union deployed against Fascist Germany. This cooperation operated purely on strategic calculation. Everyone needed Germany defeated, without requiring participants to reconcile incompatible political systems. The Valentine demonstrated that alliance warfare could function through pragmatic material exchange even when political unity remained impossible. This lesson informed post-war alliance structures, including NATO, where members maintained different political systems while cooperating militarily through standardized equipment and doctrine. Soviet veterans' memories of Valentine service reveal perspectives absent from official histories. Ivan Ivanovich Kuznetsov, Valentine driver in 1942-43, described his tank as a reliable friend during impossible times. In an interview recorded 1997, he recalled that his crew named their Valentine British friend and painted small Union Jack on turret side despite regulations forbidding such markings. Kuznetsov survived war, crediting Valentine's armor for saving his life in engagement near Kursk, where German anti-tank round penetrated turret but failed to detonate, lodging in turret interior instead. He kept that German shell as memento for 54 years, finally donating it to local museum before his death in 2001. His story represents thousands of similar narratives. Individual men whose survival depended on British engineering, Canadian production, Arctic convoy delivery, and their own skill operating foreign machines in desperate circumstances. The statistical summary of Valentine's Eastern Front service provides numerical framework for human stories. Approximately 3,300 Valentine tanks delivered to Soviet Union through 1944. Roughly 1,200 served simultaneously at peak deployment in mid-1943. Estimated total Soviet Valentine crew members exceeded 10,000 men across war. Documented engagements involving Valentine-equipped units number in hundreds. Specific kill claims and loss figures remain uncertain due to incomplete Soviet record-keeping, but available evidence suggests Valentine units achieved roughly equivalent loss-to-kill ratios compared to Soviet-designed tanks when employed in appropriate roles. These numbers represent aggregate of individual actions, specific battles, particular crews whose names mostly vanish from history, but whose contributions shaped war's outcome. German respect for Valentine, while grudging, appears in technical intelligence documents recommending capture when possible for examination and testing. Where Technische Dienststelle, German Weapons Testing Service, maintained Valentine tanks for evaluation at proving grounds, documenting armor thickness, gun performance, mobility characteristics. German engineers noted Valentine's excellent suspension system, reliable powertrain, and well-designed armor layout. They also noted cramped crew compartment, weak main armament, and limited mobility compared to German tanks. These evaluations, while technically competent, missed strategic significance. Germans built better individual tanks, but couldn't build enough of them. Valentine represented opposite philosophy, adequate tank in overwhelming quantity, that ultimately prevailed. The Valentine story intersects with broader narratives about industrial mobilization, alliance warfare, and human endurance under extreme conditions. British engineers designed it as compromise between capability and manufacturability. Canadian workers built it in facilities originally dedicated to peaceful production. Merchant sailors delivered it through hostile seas. Soviet crews fought in it despite knowing its limitations. German soldiers faced it recognizing both its weaknesses and the industrial capacity it represented. Each participant contributed to system enabling Valentine's deployment and combat effectiveness. No individual component, design, production, delivery, employment sufficed alone. Success required integration of multiple capabilities across ideologically opposed societies cooperating from strategic necessity. The Valentine ended service not through catastrophic failure, but through gradual obsolescence, perhaps the most appropriate conclusion for this pragmatic design. By 1945, Soviet tank parks included minimal Valentine numbers, most having been lost in combat, scrapped after irreparable damage, or converted to non-combat roles. The few remaining served training units and occupation forces where combat likelihood remained minimal. Last documented Valentine combat action probably occurred in Manchuria during August 1945. Soviet offensive against Japan, though verification remains uncertain. The Valentine's service life, 1941 through 1945, encompassed entire Soviet-German war, testimony to design adequacy, if not excellence. Post-war Soviet armor development benefited from Valentine experience in ways rarely acknowledged in technical histories. Reliability improvements in T-54 engines reflected lessons from Valentine diesel performance. Improved vision devices in 1950s Soviet tanks incorporated features studied in British equipment. Manufacturing techniques enabling rapid production of T-54-55 series, eventually over 90,000 units, most produced tank design in history, owed debt to Valentine production methods emphasizing manufacturability. These influences operated subtly through accumulated engineering knowledge rather than direct copying. But Valentine's contribution to Soviet tank development extended well. The forgotten nature of Valentine's Eastern Front service reflects broader historical amnesia about aspects of World War II contradicting preferred narratives. Soviet histories emphasize self-reliance while minimizing Allied aid. Western histories focused on Western Front and Pacific theaters where Allied armies fought directly. The Valentine story, British design, Canadian production, Arctic convoy delivery, Soviet employment, fit no single national narrative cleanly. Consequently, it fell between historiographical cracks, remembered partially or incorrectly when remembered at all. Recent scholarship benefiting from Soviet archive access has begun correcting these gaps, but popular understanding remains limited. Most people familiar with World War II armor can describe Tiger or Sherman or T-34 characteristics. Far fewer know anything about Valentine despite its numerical significance and strategic importance during critical period. This historical recovery matters not for antiquarian interest, but for understanding how wars are actually won. Popular military history emphasizes decisive battles, brilliant generals, revolutionary weapons. These elements exist and matter, but wars, especially total wars involving industrial economies, are won through sustained production, effective logistics, adequate equipment available when needed. The Valentine epitomizes these unglamorous necessities. It wasn't revolutionary technology. No single engagement turned on Valentine presence or absence. Yet aggregate Valentine contribution, tanks available when Soviet production couldn't meet needs, crews brought home alive to fight again, defensive positions held enabling offensive operations elsewhere significantly affected Eastern Front fighting during period determining war's outcome. This contribution deserves recognition equal to more celebrated weapons and campaigns. If this story revealed history you never learned in school, like and subscribe for more documentary narratives about the real complexity of World War II. Tell us in comments what surprised you most about the Valentine Soviet service, and join us next week for another deep examination of the technology, strategy, and human experience that defined the 20th century's greatest conflict.